the last time you boarded an airplane? Now, while you were standing in line, maybe you were thinking about how uncomfortable the seats are, or maybe you were thinking about how much work you would get done on the flight. But what you should have been thinking about is how you're trusting an aluminum can to defy the laws of gravity and propel you hundreds or thousands of miles through the air. As an aerospace engineer, I am amazed by what an aircraft can do. I am also in awe of the complexity and innovation that is involved in designing this system. Take, for instance, the Boeing 787 Dreamliner. This aircraft has over 2 million parts on it. Not only that, but the aircraft was designed by 47 companies located in 10 countries. You see, in addition to developing this technologically advanced system, Boeing had hoped to globalize their operations. By distributing their design process, they had hoped to increase their innovation while also decreasing their costs. But instead of a cost reduction, the Dreamliner went from an expected $6 billion cost to over $30 billion in development costs. I'm guessing you're wondering why the significant cost increase at this point. Well, one of the contributors to the cost increase, according to Forbes, is the significant challenge faced in coordinating decisions between the different designers. And this problem will only become more prominent as other companies also move to globalize their design process. This is the challenge my PhD thesis addresses. How do we prepare aerospace engineers to become more coordinated decision makers in a complex, globalized environment? In aerospace engineering, students learn how to design the engine, size the wing, calculate aircraft stability. But as I learned in my undergraduate career, you really have very few opportunities to integrate all this knowledge into the complete design of an aircraft. So I wanted to make my thesis both identify strategies for coordination, as well as provide opportunities for students to practice their coordinations within the constraints of an academic environment. But the only problem is that no one has ever considered how you coordinate design decisions before. So I connected the aerospace engineering design process to research findings from organizational behavior and psychology. Then I identified good and bad strategies for coordination using observations of student teams in an aerospace engineering design course. For example, one of the strategies I found is that students should have a task leader. Essentially, they should designate someone to monitor and connect the tasks of the different team members, but not necessarily be in control of all the technical aspects of the project, because that could lead to a bottleneck in the design process. In the future, I want to work with industry to expand my findings and make it applicable for more than just aerospace engineering. I also want to make my findings work in industry for professional training, for training professional engineers. So, the next time you're standing in line waiting to board your flight, think about all the innovation that went into creating that aircraft. And think about the innovation that's possible once engineers are fully prepared to interact in this globalized, complex environment. Thank you.